with it. Okay. So this is open whiteboard for the derivatives test units 2 and 3. So before starting with the questions, because I have the reviews for both units at the point, I'm going to go over, I think, the most difficult derivatives, and then you can tell me if I get any of these wrong. And these are the inverse trigonometric derivatives. So we have cosine, we have sine, we have tangent, or well, all these are arc cosine, arc sine, arc tangent, and they could be either written as arc cosine or cosine to the negative one. Just have to recognize that. So the first two, and I'll say these as I continue to write these down. The first two follow the same formula. So for cosine, it's the negative form. So we put -1 on top over root 1 minus x squared. And then the sine variety, we have 1 over root 1 minus x squared. So it's just the sine that gets flip-flopped. It's the same thing for tan and cotangent, essentially. Tangent is the positive one, so it's x squared plus 1. 1 over x squared plus 1, or 1 over 1 plus x squared. I think more often you'll see the answer like this, just because it fits with the others a little bit better. So, secant is the negative one because it's.
Excuse me.
What?
Wait, I wasn't really paying attention. Is that a plus or a minus on the cotangent?
Yeah, it's plus.
Alright.
The secant is the -1 for the. I guess it's the inverse trigonometric functions. And these are the strangest. So you have the 1 over absolute value of x, and then there you have x squared minus 1. And cosecant is the positive version of this. So essentially all these you have to remember, it's 3 pairs. The negative ones are cotangent, cosine, and secant. Positive.
Hey Jacob, I thought secant was positive.
I think it's negative.
I'm pretty sure it's negative as well, because like the cosine one's negative and the secant's the opposite of cosine.
Yeah.
I'm on the Google right now, and everything is showing that secant is positive and cosecant's negative.
Oh, maybe
this is showing that it's the other way. Yeah, I guess it is. I don't know why I remember it that way.
Yeah, even Mr. Bishop's Math Resources says that I'm right.
Yeah, because. So I guess all the ones that start with C. This looks like an S, but it really should be a C. It should be.
You wrote Soki-san.
Yeah. So all the ones that start with C are negative, and all the others are positive.
Well, that's a good mnemonic.
So I guess I should be able to remember it that way pretty easily, but you can see how easy it is to just slip up. And on a multiple choice, that will be the difference between the negative and a positive will be like putting the wrong answer. So let's get on to Unit 2 review. Wait, can you in stream see it? No, right? Let me share my whole screen.
Ooh. Yippee-ki-yay.
Okay. So, let's start. So, find the average rate of change in the interval. These are easy because it's just finding the value. What are you doing now? Okay. You just find the value at 1 and you find the value at 7, for example, in this instance, and then divide by 6. I don't think if you have a calculator for this, I don't think there should be any problem. There's not really anything new. Let's see what it is in this instance. My calculator is giving me 0.32. Is that right? Oh, just put ln 7/6.
Oh, hey Jacob, the reason that you had the inverse trigs backwards, maybe because Karen put it backwards in her slit.
That
Oh,
is why, because I
Bro,
tried
I'm
to
gonna go.
I tried to memorize it, and then I was like, it's the way I didn't think it was. So
Karen,
that's
are you
funny.
trying to Karen, are you trying to tank Jacob's class rank?
But is she in this
Oh.
call?
No, she's not, but she may watch it later.
Yeah, I hope she watches this with regret. If I forget this tomorrow, it'll be sad. But the C rule, I think, will make it easier to remember.
All I see is negatives.
Let's skip over some. Let's skip over the average rate of change. Find the derivative of this by using the definition of the derivative. I don't know if we'll have multiple choices that require you to use a certain method. I mean, we know that it's going to be a lot easier to solve it just using power rule, but that also gives us the value that we're going to get just in case we do something wrong. So in this case, we can do 2. We're doing 2x plus h squared it's plus 3x plus h minus 1. Then we can ignore the 1 because we know that we're just going to subtract this all by 2x squared plus 3x minus 1. So we cancel out the 1s. If we further simplify, 2x squared plus 4xh plus h squared. What? Okay. If we further simplify this, just so these are going to cancel. We're left with all this over this. And further simplifying, we can just take out an h. And we know that h is going to be 0, so we can take out this. So after the mass simplification, we just end up with 4x plus 3. This is the same as this. Obviously, doing this was a lot faster, but it asks us to use the definition of the derivative. This is something that you should memorize. The limit as h approaches 0 of f of x plus h minus f of x over h. Just because you'll sometimes be given something, a derivative in this form, and you'll be asked to define it, and it'll be a lot easier if you can just take the function out and solve it using power rule or some other derivative rule. Okay, so let's move on to this section. We don't have to do all these, but we can do a couple of them. So let's start with this first one. 5, 4. So we want to find the derivative of 4 minus 1 over 2x squared. So when you see something with an exponent in the denominator of a fraction, you know that it's going to be negative, that exponent. So we can turn this, we know because of the constant rule, that when you take the derivative of a function of a constant, it just becomes 0, so we take that out. Then we just use power rule to get 4 over x to the third. So that should be the answer to this question.
Wait, is that right? Because isn't it 1/2 times x to the negative?
Oh yeah, it should. I don't know why I made it.
That's all right.
I don't know why I did that. So yeah, it should just be 1 over x to the third.
Yeah, I was gonna remind you to group the throw some parentheses around the 2x.
Yeah. So this will help you from making. This will help prevent you from making that mistake. Because it's still going to be in the denominator when you move the x up to the numerator. Okay, we can do a couple more of these. Here. Here's one with the e to the x minus 2 cos x. Okay, this is one that uses two rules. One is just that the derivative of e to the x is e to the x, and cos x is sine x, or negative sine x for that matter. So it should just be 4 e to the x plus 2 sine x. Yeah. Another thing to remember is that the constant rule extends even to e to various exponents. So if you see something like this in your answer, it's likely trying to trick you. This is still a constant, and it just gets turned to 0 just like 4 would. You can think of it as you can solve this for a numerical value. You can't solve anything in here for a numerical value without knowing what x is. Here, let's do one with quotient rule. Now, because this goes a long way back, remember that not everything using a fraction with exponents, with variables on both top and bottom, is going to be necessarily a quotient rule problem. I think this one is, but there are some cases where you'll have, when going back, you'll have something like this, and you can just simplify before taking the derivative. Makes it a lot easier. So, I mean, if you remember quotient rule from past, you remember the low d high minus high d low over the square of what's below. And I never used that until I started forgetting some of the stuff. So low times the derivative of high, x plus 2 times negative 1, and high minus high times the derivative of low, 2 minus x times 1. I'll put 1 there. So negative x plus 2 minus 2 plus x over x plus 2 squared. Okay, let's see how to do this. Let me just share. This should be minus 2. Yeah, so they did do it with the quotient rule. So it's going to be negative 4 and the square of what's below, so x plus 2 squared. So that's how to solve this problem. I don't know how much of our test is going to be this, but I'd say a considerable. There will be at least a couple questions that are just relatively basic derivative. Okay, find the equation for the tangent line. So a lot of these are just like a little bit of an extrapolation from the basic derivatives, because when you find the derivative, you're finding the slope. So if you're finding the equation of a tangent line, you just have to first find the slope. So here, let's try to skip it and jump ahead to this one. So f of x equals 3 sine x minus 2 e to the x. Find the derivative of f of x at 0. So first we'll just take the derivative. Remember, e to the x stays the same. Sine x is going to turn into cos x. We know that cos x at 0 is 1. So we do 3, and anything to the power of 0 is 1. So we know that this is going to be 2 times 1 or 2. So we just get 1 for this. And that should be, yeah. So actually there are simpler ones here. Because it's 0, the slope is 1. It's not asking to find the tangent line. This is just really. I'm interested in what this is. I actually haven't seen this before. The normal line. This may just be.
We went over this.
Is it just perpendicular to the tangent line?
Perpendicular to the tangent line, yeah.
Okay, I just forgot that was the word for it. And here, let's just do one of these real quick. So x equals 1, negative 1. So we can start by just solving for y. In this case, -1 to the third power is -1, so that's 2 minus 3. So we know we're starting at -1, -1. And we can solve this for slope. We can just do a quick power rule. And then at -1, we get -3 for the slope. And then just using this, usually you can just leave your equation in point slope form. So it looks like this. It's y minus h x minus y minus k x minus h. So x plus 1. And you may have to simplify this if it's a multiple choice setting. If not, you can just leave it like this. Alright, calculator is allowed on the following problems. If you don't remember how to get to the derivative function on the calculator, it's in Math 8, d of dx. So for this first one, you can just, I think for both of these, you can do it entirely in your calculator. With chain rule, it's possible to do either of these without your calculator, or maybe it's difficult to solve, but you don't need to use the derivative function. I can't share my calculator right now, but for this one I actually got, let's see if that's actually, yeah, it is 260.246. I thought that was a little high. Remember, cosecant is 1 over sine, so if it asks you for this, you just put 1 over sine. Make sure you use a lot of parentheses, as always. This should be fairly standard stuff. That's what this one is. It's -37, yeah, -36.89. And I guess you should round to 3 decimals where you can. Okay, if you're asked to estimate using a table, I believe you just find essentially the secant line between the two nearest values it gives you. So these are going to be 60 and 180 here. We do 808 minus 412 divided by 120. Let me make sure that this is how it wants you to do that. Yeah. So that's simple enough. Is the function differentiable? If the function is differentiable, it has to be continuous, and it has to have the same slope on either side. So if we plug in, 2 here, 6 minus 12 minus 5, that's -11. And 7 minus 18, also -11. The slope of this is -9. You can see that just by using a quick power rule. Then this is going to be 3 minus 6x, which is, this is also -9. So the function is differentiable. Here you would do similar things. You would just set up a system of equations, set these equal to each other because it has to be continuous, and then set the derivative of each equal to each other because it also has to be differentiable. I'm not going to solve that because I would like to keep this video relatively short. So let's move on to the review for Unit 3. Unit 3, I would generally say, has the more difficult problems. As you can see, there are only 10 questions in here, but they tend to be longer questions. So here we have a lot of chain rule. A lot of these are chain rule, actually. We have implicit differentiation and inverse functions. So I'm going to go over all of those again real quick. The chain rule, the chain rule is written out like this. You take the derivative of the outside times the inside times the derivative of the inside. So in this case, we have cos squared 4x. You can just write that as cos 4x and then all that squared. So actually in this case you need to do 2 sets of chain rule because cos 4x you can't take the derivative of without chain rule. So we know it's going to be 2 cos 4x But then for what it's multiplied by, we have to do another chain rule. So this would look like negative sine 4x times 4. So it's negative 4 sine 4x. And then you just multiply that all out. I think this would be negative 8 plus 4x sine 4x. Let's see if I've done that all right. Yeah. So often you will need to use the chain rule multiple times if you have a problem like this where you can't differentiate any part of it individually. Let's do this one implicit differentiation problem over here. This is x squared and y. So I think we just assume that it's going to be the derivative of x with respect to y. When we take x squared, we can just use power rule. There's no problem. But when we do the y to the fifth, we actually have to use chain rule because we can't take derivative of this. We know that the derivative of y is just the derivative of y. But first we have to do 10y to the fourth, and that can be multiplied by y prime, or the derivative of y. And on the other side, we have to use the product rule in addition to chain rule. So we're going to have 10y plus, and so that's the derivative of 10x times y plus the derivative of y, which is y prime, times 10x, so 10x y prime. Let's get all the features with the y prime onto one side, so 10. And let's actually simplify this. We can divide everything by 2 at this point. 5y to the fourth y prime minus 5 xy prime equals 10y minus 2x. We can then take out a y prime here. And then, you know how it goes from here, we can just divide both sides by this. Now, if we were to ask for a second order derivative, you may end up having to plug this original equation into the second derivative because you're going to have y primes in this, but you've already solved for y prime. So let's picture this, right? Oh, I did something wrong here. Where did I go wrong? Oh, I didn't divide everything by 2 properly. I just divided that side. So that's going to be 5 and 6. Or 5y to the fourth minus 5x. Alright. Here goes some. Okay. Let's go for each of the. Okay. These are derivatives of inverse. But we're getting quite filled up here. So we just gotta remember here, if gx is the inverse for all x, we wanna take the derivative of gx. That's equal to 1 over the derivative of f of g of x. So in something like this, where it gives us all the values, we actually have to find g of x. So we have to find g of -1. So g of -1 is 6 because in an inverse function all the x and y values are swapped, and we see -1 is the y value at x equals 6. So 1 over f prime is 6. That's going to be 1/3. Now here's one where it actually gives you a function, and it gives you g of -3. So you just plug that in here and then you take the derivative. I'll skip this problem. See, we already know how to do that. And now here's the last type of problem we're gonna go over. And then I guess I'll open up to questions in the video. So find the second derivative based on the given information. Our first problem is y equals x to the fifth minus e to the 4x. So what's going on?
What's up, Beijing?
Your background noise is very loud.
Oh, sorry.
You wanna watch me take the second derivative based on given information?
You're doing homeworks instead of AP Classroom for practice?
This isn't homework. This is the unit review.
Oh,
And I did the AP Classroom.
I did it and I like kind of failed, but
Yeah, me too.
Make it hard.
what?
Okay, let's take
Make it hard.
Oh, too easy for me. I got you.
let's take a second derivative. Tom, you can give your opinion now. Does this look good?
Looks good. Very
let's,
good.
Let's see. Yeah, it's good. So here when we have e to the 4x, we just bring out.
Should I do the full review packet? How long is it?
It's just 30 questions. We did actually most of the packet in this time.
Oh, nice.
I'll just do one more question from this. We're at the very end. Define the equation of the tangent line.
The AP Classroom. He has like a
This
first.
one. This one we have y's on both sides, so we're going to be forced to use implicit differentiation again. 2x plus 14y y prime equals 24 y squared y prime. So we gotta solve for y prime, so once again, let's divide everything by 2. We can do it right this time. And then we'll move over all the features with y prime over into the left. And take out y prime. We're just gonna go with 12y squared minus 7y. And x over 12y squared minus 7y is y prime. But we're not done yet because we have to plug these numbers in and find this slope. So it's going to be negative 6 over 12 times 2 squared, which is 2448, minus 14, negative 6 over 34. I surely have done something wrong. Let's see. No, it's just a really annoying. It's just a really annoying slope. Okay. So negative 317. And we can, once again, we can just use 1 minus 2 equals negative 3/17 x plus 6. Alright. So I think we've gone over most of the topics. So I'm going to cut the video here so it doesn't get too long. Thank you for watching.